Well, hello, and in this exciting video I'm going to go ahead and try to demonstrate IBM mainframe SNA networking using a Hercules virtual router that's been patched to do what's known as DLSw, which is like a virtual serial circuit to a Cisco router, which in turn will translate it into DLC SNA traffic that runs on Ethernet. So that basically, using all emulators, we can talk to a emulated mainframe. So this should be exciting. When we're all done, this is what we should be achieving. This is an empty virtual machine, so I want to just go over all the steps required. So we're definitely going to need a copy of 7-zip downloaded. We also need a copy of Wireshark for Windows x64, and then we need the download file from this DLSw lab I've set up. Links will be in the description, so you don't have to worry about this too much. So let's go ahead and close that window. I've already downloaded the files, so we can start with the install. So the first thing we're going to do is install 7-zip, unless you've got a way already to decompress that. It's not too involved. So now I should be able to right click on here, 7-zip, and extract here. And now we should have all the hard drive emulation images, Cisco router, Windows 3.1 machines, everything required in this nice directory. I'm going to go ahead and cut this from here. And like a good user, I'm going to put this on the root of my hard drive. It's an emulated machine, so I don't care. It doesn't matter to me. Alright, so back to your downloads. Next thing we need to do is we need to install Wireshark. So Wireshark is a capture packet program that'll let us to see what's going on the network. And more importantly, it lets us inject packets from an emulator onto the network. So the default options are fine. Let it live where it wants. This is important. We do need to install npcap. We don't need to capture USB, so that's fine. So we'll do the first part of the install for Wireshark. Alright, here we go. And then it will start the install for npcap. The biggest thing here is you need to make sure you install the WinPCAP API compatibility, because these emulators I'm using are a little bit old and I just haven't gotten around to updating stuff. So install the compatibility, things will work. Alright, so just let this go for a minute. Alright, now we have our packet sniffer. Now the next thing we're going to need is let Wireshark finish installing, and then we're going to need to set up 2 network interfaces. I guess in a way we use Paint to kind of explain this. I'm sorry, this is going to be really crude drawing, but we're going to have 2 virtual networks. We're going to have a Cisco router in the middle, and we're going to have our Windows 95 machine here, and our mainframe here. So let's put some labels on stuff. Over here we talk TCP IP. Make this a bigger font. Of course, you do it weird. There we go. We don't need to worry about backups. And over here we're going to talk what's known as SNA. I can type. This is our Windows 3.1. This is going to be our Cisco router. And over here will be our mainframe. And of course, the magic we're going to use here is DLSw. And then we come back home, we want a line tool. It's a dark color, it will show up. So the mainframe is going to talk DLSw to the Cisco router. TCP/IP connection is going to be Cisco router to here. Oh, I changed the color on me there, didn't it? Because it's a different line. Whatever. And if I go light blue here to here, oops, not here to here. It's basically Windows 3.1 to this network, and the Cisco router onto this network. Oh, and then I guess in the middle here is our Windows 10 machine. Oh, come on, maybe see it. Put you in black. And we'll give you a geometry shape of, I guess you can just be a square. Okay, so almost everything here is going to be virtual. We're on a virtual mainframe speaking this DLSw to the Cisco router. Cisco router is going to have a TCP/IP connection that goes into the Windows 10 machine, and then from Windows 10 it's going to connect to the mainframe. So using TCP/IP here, it's going to emulate just a straight connection of DLSw straight to the Cisco router. Then on one interface Cisco router, it's going to speak SNA, and that's going to let the Windows 3.1 machine talk to this SNA network, get translated to the Cisco router, DLSw, to the mainframe. So logically, this is what happens here, and then physically, Cisco routers can speak TCP/IP down to here, through Windows 10 to the mainframe. Let's pick another color, like green. So, no, don't change that color. Fine. So we're going to go ahead and try this again in green. So logically, the flow is going to be Windows 3.1 to SNA, and then it's going to be from SNA to the Cisco router, and then Cisco router to the mainframe. So logically, that's what happens. To make it physically work, that's where Cisco router needs to have TCP/IP to come in here to talk to Windows. And then the mainframe emulator is just a program running on Windows that's going to pick up that TCP/IP connection. All right, I hope this is clear as mud. This is about as easy as I can kind of think of making it. I can leave that connection here, that's fine. All right, so there's our reference drawing of what the heck we're going to be doing. So now it's time to do it. I'm going to go ahead and bounce between desktops because this makes it so much more easier for me. So we're just going to let Wireshark finish going back here. So now I'm going to leave my drawing and create a new desktop. And I'm going to go ahead and just create a shortcut to cmd.exe or command prompts. That'll make life a lot easier for me. All right, we're going to call this one here MVS. And that will be for our mainframe. And coming back here, we're going to make a new one. And this is going to be Cisco router. And of course, that'll need a command prompt. And then finally, we want our SNA client. So we're rename this one here to SNA client. Alright, so remember we moved everything to the root of the hard drive. So the mainframe stuff lives in this directory called TK4. And all you have to run is this MVS batch file. Everything's pre-configured as far as adding the DLSw and additional terminals. I didn't change anything else. So from here you can just literally type in MVS and we will be ready to start the mainframe. But before we start the mainframe, let's get the Cisco router going. This is a little bit involved, but not much. So this is going to be in the Dynamix directory. Oh, I'm jumping ahead of myself. Going back here, we need to create these virtual Ethernet interfaces. So the easiest way to do that is Device Manager. So one of the ways to get to Device Manager is you right-click on my PC, and I believe it's Manage. Yeah, there we go. Just close this window. Then we go to Device Manager, and then we should go to Action. Or no, I think you got to click up here. There we go. Now we can click on Action, Add Legacy Hardware. All right. So when I go into here, I already know what hardware I have, so that's the manual. Then we go down here to Network Adapters. The manufacturer is Microsoft, and this is the one we want, Kernel Module Test Loopback. So we're going to do this twice because we want two of them. So just to verify, if we open up the networking tab here, so we have our physical Ethernet, we got one virtual network, and now we're going to add our second. So manually, network adapters, go through the vendor to Microsoft, and then scroll down to kernel module test. And next, and finish. All right, excellent. So now we have our two network adapters. Now, to complete this mapping here, we need to bring up control panel. If it lets me type. Control, there we go. Now we're going to type in view network connections. I found this is just the easiest way to get around Windows. Okay, so you can see we've got two Ethernet interfaces here, and they're both stuck on identifying. So first I'm going to rename the first one to loop_TCP/IP. The only thing we're going to do here is we're going to give this thing a static IP address to make this easier for ourselves. I have everything already set up to go on 192.168.1. We can just put in the IP address netmask like this, and you can basically leave everything else alone. I'm going to turn off IP6 because I don't need it and I just don't like it. It's important that we have our fixed IP address here, and of course it's bound to the NPCAP protocol because that's how the emulated Cisco router is going to talk to it. Now for our next network, we're going to go ahead and rename this one. We're going to call this one loop_SNA. And we're going to bring up its properties. So for this network, it's not going to talk TCP/IP. So it means no clients, no file printing. We leave these two here. No TCP/IP, 4 or 6. And hit OK. Alright, so now our network interfaces are not complaining, so that's good. Now it's time to bring up the Cisco router, which is the glue in the middle. So we go down here to Task View, go to our Cisco router. And the first thing we're going to need to do is list our Ethernet interfaces. So we type in eth list, and this will show the network interfaces that we have. So we had 3, our physical Ethernet, the loopback for TCP/IP, and the loopback for SNA. So I'm going to go ahead and copy this and put this into Notepad, because we will need to know this stuff. And if we do a dirn here, you will see that there is a command file, router.cmd. So I've tried to make this somewhat easy, but it's still involved, I know. Alright, so we have loopback and VMnet1. So originally I configured this on VMware, and VMware already has dummy interfaces, VMnet1 and VMnet8 with TCP/IP bound. This machine doesn't have it doesn't have VMware installed. So we need to just change these interfaces to match what we have. So VMnet1 is going to be the TCP/IP. So we're going to copy this string here, edit, copy, and we're going to bring this one here to here, and then go edit, paste. And now we want the SNA loopback interface here, edit, copy, and then we're going to go back and paste that onto the loopback interface. So try to make sense of it. The loopback SNA goes to the loopback interface, and the VMnet1 goes to the TCP/IP. So we can close this, and now we can start our router. Okay, and hit enter. The interfaces will start to configure themselves. You'll see them down, and then our fast Ethernet should change up. Hit enter again, or the router prompt. So if we do a show ver, we can see that this is Cisco iOS 12.0. Happy Thanksgiving, great, from 2000. We're going to go ahead and enable. This lets us run powerful commands. And if we do a show ARP, we can see that there's an entry here for 192.168.8.1. So it already can talk to the regular PC in here. So the Cisco router is basically configured and ready to go. If you type in ping, however, the Windows firewall will prevent this from working. So if we ping 192.168.8.1, you'll see that this is not going to work. And if I open up another command prompt and try to ping 192.168.8.5, the Cisco router, you can see it's working. As a matter of fact, I think we can telnet to it, but it might reject us because we have no telnet program. It doesn't matter. It doesn't matter. That's the price of doing this live. Alright, so we're going to go back to task view. I'm going to take this notepad, put it in the SNA client, because that's where we're going to need that next. Alright, so now we're ready to start the mainframe. So we have MVS ready to go. Hit enter. Now, Windows Defender Firewall is going to ask if you want this thing to be allowed to communicate. And the answer is yes, absolutely. So we allow. So if we're really lucky, we should not have to turn on or turn off all the Windows Firewall. But this will let the virtual router speak to the mainframe. So this will take a minute or two to process. So if we go back to our task, now we can see, so we started the mainframe, and we have the Cisco router running. So it's a matter of waiting for the mainframe to complete enough of its setup, and then the connection between the mainframe and the Cisco router will come up. So you can see that it's doing its networking turn on. I literally just edited the files that are needed for this to work and then saved the mainframe state. There we go. Warning DLSw packet loss. That's fine, don't worry. But that does mean that the area N13 is now active, and more importantly, that the mainframe and the router are now talking. So if we go back to the Cisco router here, we can type in show DLSw peers, and we can see that we actually have been up for 9 seconds. So that's the uptime here, and that we have packets transmitting and receiving. Fantastic. Now, we're going to go and get ready to actually speak to the mainframe. So for this, we're going to want the loop SNA interface in our clipboard. So I'm going to copy that. Now I'm going to go into my DLSw directory, and I'm going to go into the client, and I'm going to edit the client batch file. So just notepad client.bat, and I'm going to change this line right here. So this will just set the interface to the proper, well, interface to bind to. In this case, you can see that it has a MAC address that's specified because you can run more than one, but obviously if you're going to run more than one of them, you want to have different addresses or bad things are going to happen. And it's going to use PCAP to connect this virtual machine onto the network. So I'm going to go ahead and start this, and it will start up our Windows virtual machine into MS-DOS. Let's minimize this out of the way. Minimize this other way. Now I'm going to start Wireshark. And this way we can actually look at the traffic on the interface. So you can see we have our Ethernet, our TCP/IP loop, and in this case the loopback for the SNA. So I'm going to go ahead and double click on here, and then just maximize this. And now you can see we're now looking on that SNA interface. So just to jump back and show the drawing, our Wireshark, change its color here to red, Wireshark. it's going to be listening on here. And of course, this interface over here was loop SNA. So we should put this over here. At the beginning, this might be a little easier to follow. Loop TCP/IP. And then let's go ahead and change. I guess we'll just run this in blue. We're going to go ahead and get some geometry and show that this is the Wireshark. I thought I said blue. And then just grab a wire from here. And just to show that the Wireshark here is listening over here. Alright. So Wireshark running on Windows 10 is going to be listening to this loop SNA. So we'll be able to see the Windows 3.1 machine talking on this network and then talking SNA to the Cisco router, which again translates that traffic to DLSw to talk to the mainframe. So here's where we're going to be listening. So we go back to our window to client SNA, and we can see there's no TCP/IP, which is exactly what we're expecting because we're not going to use TCP/IP. You'll be seeing these SNA solicitations from the Cisco router, basically just telling everyone that it's alive and it's here. So let's go ahead and bring up our PC emulator. It does say network card not found. Don't worry, I don't know what the error is either, but you know what, it works. And we're going to run Windows. Alright, now we're in Windows 3.1, so the mainframe emulator is already configured. So we just hit enter for the display. And there's 2 sessions configured, so I'm going to bring up the first session, number 2. And this will just take a few seconds. And there you are. So now we are showing the initial login screen to the mainframe. I clicked in here, you can see control alternate releases the grab from QEMU. If I go back here and look at the mainframe traffic and scroll through here, you can see these U's. That should be just mainframe acknowledgement, but if we go further, there we go. That's a Cisco router doing an acknowledgement. Here we go. So this is the actual mainframe traffic showing the cat that's sleeping for the login screen. And as you can see, no TCP/IP. It's all SNA and LLC, which again is exactly what we want. All right. So let's go ahead and go back to our session here. So hit enter to log on, right? So we hit enter, connecting to TSO. You'll see more mainframe traffic. And we always going to get this error. You need to hit the, I believe it's the tension key and an extra, that's the left shift key and escape. Alright, and now we just type in log on. Enter user ID. Again, this is 100% stock. I didn't change any of this, so it's Herc01. And then the password is CUL8TR. Welcome to TSO. We'll get a fortune cookie of the day. We're going to have peace even if we have to fight for it. Nice. And there you are. So now we are logged on to TK4- using SNA. No TCP/IP. This is not Telnet 3270. This is SNA traffic, just like we used to do stuff back in the old days. And as you remember, there was 2 sessions. So we can go ahead and start the second session. Same deal, we hit enter. This part is going to have a problem. We hit escape. So it's the shift escape for the system reset. And then log on. Then we have to use the other ID, Herc02. Password. It's a dumb thing to show off, but if you type it in here, clear text, CUL8TR, it'll log us in. And hit enter. Great. There you go. Now we have 2 sessions logged into the mainframe. More or less how we did stuff in the old days. The only difference going back into here is that instead of this being a TCP/IP connection going from the router through Windows 10 to the mainframe, is we had to plug in these big old giant serial cables from the Cisco router going to a controller, and then that controller then having even more bigger cables going into the mainframe. So yeah, that's basically it. Hopefully this is what people, I guess, wanted to see, since I haven't seen that much out there in the ways of networking, you know, much of anything to a mainframe doing stuff the old way. Most people just set up a controller that emulates Telnet 3270 and then, use a modern client. But, where's the fun in that? At least now you can actually understand that, this connection here for the SNA, it is not TCP/IP. That going back to the Wireshark over here, these things are MAC address to MAC address. They only work on the same physical network. This was a huge problem back in the day because you would end up having to make these massive bridges where things could get very chatty. It was a huge problem. I mean, fundamentally, there's a reason why nobody uses this technology anymore. And I should point out that this packet here that does look like TCP/IP, it's a low-level wireframe protocol, and this is what Cisco routers do to say hello to each other, and this is called Cisco Discovery Protocol. So it'll tell everyone on that network what interface they're connected to, what type of device it is, in that case it's a router, and then what version of the operating system it's running. It's really neat for discovery, but it's kind of pointless here, and I didn't turn it off in the router config because maybe something's misconfigured. In that case, you do want to see the CDP advertisements of where you are actually plugged in versus where you think you are plugged in. So I can close the Wireshark. I've seen everything I've needed to see there. Quit without saving. And then, so there we are. I've only configured the 2 mainframe sessions because typing in this thing's a nightmare. But now that we have mainframe connectivity, I suppose you could just download the VTAM definitions and edit them offline. I think it's 1, 3, 4. Yeah, I remembered where I was last. System VTAM list. I think you can go in here and view. I believe it was the N13. Edit. Yeah, it gets very confusing, but this is part of what I had to change for the max LUs. And was it the S3705? Yeah, for the actual controller. This is the part that gets really confusing. So it's NCP Remote 13. And then yes, these are the 2 terminals I enabled. So it's local address 3 and local address 4. It's so not easy to follow. And I'm very sorry if anyone came to learn how to do NCP gens. I am definitely not the person to ask. It has taken me way too long to get this part done, but at least the mainframe config's already done. So for fellow tourists, this was pretty much as click and go as I can go. So I guess with all that said, so here we are, mainframe networking. Everything, I guess, what everyone hoped to see. So with that, I'll have to say goodbye. Goodbye!